Hi everybody. Well, as you can see from the title of this video, I'm going to talk about the baccalaureate exam on the French metropolitan area, um, continental area, mainly in France. Well, what I'm going to approach today will be the probability exercises. What is the distribution function of a random variable? What is the average waiting time, and so on. First of all, I'm going to talk about this one. A supermarket has several cash points. A client which presents himself at one cash point must wait a certain time t1 before taken in charge by the cashier. We consider that the waiting time t1, expressed in minutes, is a random variable which follows the uniform law on the interval 0-12, meaning that whatever time we take between 0 and 12 minutes, there is an equal probability of having that. What is the probability that a client waits at least 5 minutes, at least, this is the keyword, before taking into account? So, the point is that in order to do that, you need to know the distribution function of it, the probability distribution or probability density function. We say that T1 is uniform on 0-12 or mainly on AB if the probability distribution function of T1 at point X is 0 when X is not between AB. Oh shit. And 1 over B minus A when it is between these two, right? Great. Well, the point is that the PDF is 0. But what is the probability that T1, how would you reformulate the problem? That T1, that the waiting time is at least 5 minutes, that T1 is greater than 5. How would you say that? Well, is the, in our case, T1 being distributed uniformly between 0 and 12. So, what is the distribution of this? Well, because T1 is between 5 and 12, the probability from 5 to its maximum, which is 12, of the PDF of T1, which is 5 from 5 to 10, integral from 5 to 10, of what? What is the probability? Well, 1 over 12 minus 0 dx, which is 1 over 12, taken from 5 to 12, which means that it's 1 over 12 times 12 minus 5. Because the integral of a constant is the constant times the length of the interval, which is 7 over 12. Good. That is the probability that a client waits at least 5 minutes. If the question would have been, what is the probability that it waits at most 5 minutes, it would have been integral from 0 to 5 out of 1 over 12 minus 0, the density probability density function, right? So this would be from 0 to 5, 1 over 12, which is 5 over 12. Actually, it's very logical that it's either between 0 and 5, or lower than 5, or greater than 5. So that would be actually 1 minus the previous probability we found out. It's quite simple. Good. The second question of the problem is what is the average waiting time. Actually, this is mathematically written as average expected value of t1. What is the expected value of a random variable in general? Expected value of x is integral from 0 to infinity of x times the density of random variable x in the point x dx, or here more generally minus infinity to infinity. But in our case the density is 0 except the interval 0, 12. So it's integral from 0, 12 from out of x times the density, which is 1 over 12 dx, which would be integral from 0 to 12. Well, we get out the common, the factor 1 over 12, and we have integral from 0 to 12 of x dx, right? So in this case, this would be 1 over 12 times x squared over 10 over 2 from 0 to 12. What is this symbol? Meaning that we differentiate, we make the difference between x squared on the 12 point and 0 point, which will be 1 over 12 times 12 squared minus 0 squared all over 2. So this would be 1 over 12 times 12 squared over 2, which would be 12. 1 reduces with the second power over 2, which is 6. What is this 6 meaning? Meaning the average waiting time at the cache point. Well, that's it. Le temps moyen d'attente à la caisse. Voilà. If the waiting time, would have been distributed differently, let's say t would have been distributed uniform from 3 to 6. Let's play with the figures. What would have been the average waiting time? Well, the expectation would have been integral from 3 to 6 of x times the distribution, which is the 1 over 6 minus 3 dx. This is actually the density function, the probability distribution function. You must make a difference between probability distribution and function distribution or repartition. We will discuss later. So it's 1 over 3 times integral from 3 to 6 out of x dx, which is 1 over 3 times x squared over 2, which is 1 over 3 times 6 squared minus 3 squares over 2, meaning 1 over 3 times whatever is this, 36 minus 27, which is 9 over 2, which means 3 over 2, which is 1.5. Voila. Good. Let's get to the next point. The shop manager decides to put available for the clients on the disposition of clients automatic cash points in order to reduce waiting time for the clients having baskets containing few articles. The waiting time T2, expressed in minutes at each of these automatic cache points, is modeled by a random variable which follows the normal of average 5 and standard deviation 1.5. compute the probability that a waiting time be between 0.75 minutes and 6 minutes. Voila. Well, some French people, especially those who are not specialized in mathematics, use some computer to do that directly. Meaning that on the computer, on a hand computer, they're not allowed with electronic devices, but with a pocket computer they are allowed. So actually this is very simple for these guys. Well, T2 is modeled by a normal of average 5 and standard deviation 1.5. But let's assume, of course, you need a computer to do this. You cannot compute this because the integration is from, well, what is actually requested. What is the probability that 0.75 be lower than T2, which also on his turn be lower than 6? Well, of course, this is the probability that T2 is lower than 6 minus the probability that the T2 T index 2 will be inferior to 0.75. So, of course, a French guy would immediately put mu equal with 5 and sigma with 1.5 and would compute this probability, or at least these two. But suppose I don't allow you to do that. This is a new normal of mu sigma. Pay attention, not sigma square, not the variance, but the standard deviation, which is different. And suppose that you have only a table with normals of 0, 1. Namely, you know that the probability of normal 0, 1 be inferior to a certain x that you have as input. But you don't have actually the real, the probability on a more parameterized way, only the standard normal variable. Well, in that case, how would you convert T2, which is not a standard normal random variable, to a standard one? Very simple. We use the rule that x is normally distributed of mu and variance sigma squared. This is the average mean, and this is the variance. If and only if x minus mu over sigma is distributed n of 0, 1. So in that case, I would have to convert T2 in a normal of 0, 1. So separately, I will treat each term as probability of T2 minus 5, which is the average of T2, over the standard deviation 1.5, as being lower than 6 minus 5 over 1.5, which is, at its own turn, probability that a variable z, which is distributed normally, standard normal, like this, be inferior to 1.1.5. I don't know what is that, but I will find out. Let's see. 1 point that. It's going so slow. Yeah, whatever. Next. So that would be normally like this, and it's a notation, so don't get too confused with this. N of 1.1 over 1.5. The other one, probability that T2 is lower than 0.75, is just the probability that T2 minus 5 over 1.5, the same shit, is inferior to 0.75 minus 5 divided by 1.5. You compute this is n of minus 4.25 over 1.5 and so on. And you compute that, and of course, n, the probability of this is 1 minus this last normal probability is 1 minus n of 4.25 over 1.5, based on the rule that normal of minus x, normal cumulative distribution function, is 1 minus n of x. Why is that? Because the left and right tails are symmetric. Namely, the right probability to the x and the left to minus x are the same. That's why. And it remains something in the middle. And that's why, because of the symmetry, somehow you see that if I take this mu and this, the PDF of the normals, right? If that would be, I don't know, sorry, this if would be, sorry, we are talking about normal of 0, 1, so again, normal 0, 1 must be centered around 0, so it would be like this. Well, if that is minus x, I suppose that, and this is x, we'll see that the probability of normal being lower than minus x is the area of this surface. On the other hand, the probability that it will be superior to x will be this, which is symmetric, which means it's the same. And it remains this whole area. This is somehow a proof of this relation. Anyway, you have this, and the bottom line of the exercise is that the probability requested, which I would call prob, is n of, above here, 1 point over 1.5 minus parenthesis 1 minus n of 4.25 over 1.5. Good. Good. The next one, exercise number 3. This one is different. These automatic cache points sometimes break down. The number of cache points is 10. The probability that our automatic cache point fails to work during a day is 0.1, meaning 10%. And these cache points are independent, meaning that a failure on one doesn't influence the others. Let x be the random variable corresponding to the automatic number of cache points which fail to work. First, what is the probability law of x? Well, this one is not mathematics, it's logic. You have for each cache point you have two choices. Either it fails or it doesn't, which means which is a binomial distribution. Binomial means what? A number of n simulations, independent, and a probability of an event to happen. So it will be a binomial of n and p. Who is n? It's 10. Actually, it's suggested by the problem, and p is 0.1. So the answer to the first question is quite simple. And I will put it down here. X is distributed binomial of n and p. meaning of binomial of 10 and 0.1. Point B is a little more interesting. Compute the probability that no cache fails during a day. P is the probability that a cache point fails. So the probability that a cache point doesn't break down is what? Well, 1 minus the probability that it breaks down, which is 0.9. How is binomial distributed? Well, x is said to be distributed like above if the possible range of values is 0, 1, 2, n, representing what? The number of cache points which fail to work during a day, which is combinations of n taken by 0. Here I put a general k and I will write down the general formula. Combinations of n by k of p times k at the k power times 1 minus p at the n minus k power. This is general. Probability that x be equal with k is this combination times the probability p at the k power times 1 minus p at the n minus k power, right? That's the whole point. So the probability that x is 0 actually is the combination of 10, because n is equal with 10. K is 0. This probability is not the above, is the probability. Actually, it is 0.1 at the 0 power times 0.9 at 10 minus 0, which is actually 1 times 0.9 at the 10th power. Voila. That's which is actually pretty low. It would be like, I don't know, let me compute this. Come on. 0.9 and the 10th power. Yeah, it's very, very slow. It's 34.86%. Excellent. Well, that's all. That's the probability that no cache point fails. What if, and I'm always working like this, what if I would have been asked, what is the probability that one cache point fails? Well, that would have been combinations of 10 time taken by 1 by number of actually what does it represent? Number of subsets of one element from out of a set of 10 elements times the probability p at the first power times 1 minus p at 10 minus 1 power, which is actually 10 factorial over 1 factorial times 9 factorial times 0.1 times 0.9 at 9 power, which is 10, 1 times 2 times 3 times 9, which it reduces actually, it's 9 factorial if you like, multiplied by 10 over 9 factorial times 0.9 at the 9th power, which is 10 multiplied by 0.9 at 9th power. I'm very, very curious about this. 0.9 times 10. It can be, wait, the probability is too big. Actually, on the, yeah, I've made a mistake here. It's, the first one is correct, actually. No cache point fails, but on this case, yeah, I forgot to take 0.1 here. Yeah. The mistake was being by lack of attention. You must always pay attention to these details, which actually is 0.9 at the 9th power, because 0.1 times 10 is 1. And this, I'm using Python. It's like shooting flies with atomic bombs. It's 38.74%, which is actually very, very big. So, 38.71%. And look at this situation. The probability that no cache point fails was 34%, almost 35. And this one is almost 39. Together they form probability that x belongs to 0 or 1 would be 34 point, I don't know, blah blah blah, 86 plus 38.71%, which would be 75.3 which is huge. So imagine that among the 11 possibilities you have from 0 to 10 cache points to fill, the first two concentrate 3/4 of the possibilities. That is a huge tail on the left side, and a very thin tail on the right side. You'll see. You can ask yourself, what is the probability that all cache point fail? As a little homework, which would be combinations of 10 times 10 taken by 10 times 1 minus p at the 10th power, which is 0. Sorry. It would be p at the 10th times 1 minus p at the 0 power, which would be p at the 10th, which would be 0.1, attention, at the 10th power, which would be very, very low. 0.000000001. 9 of zeros and 1 after that. So that's what I mean by very thin right tail. You'll if you do college in math, you'll understand better what is left tail, right tail if you do probability courses. Of course, the last one on this topic, on the opening, on the front side of the shop, the shopkeeper of the supermarket displays: more than 90% of the clients of our magazine are satisfied by our automatic cache points. A consumer association wishes to examine this statement. For that, it realized a poll. 860 clients are interrogated, and 763 out of them are satisfied. This may put into question the previous statement or not. Well, you would say that if you do a basic ratio between the number of satisfied clients and the total number of clients, right? You would have a basic probability of 763 over 860, right? Right. That's the probability. Well, we'll see if that is 763 or 860. Well, it's 88.72%, which is not very far from 9%. But it's lower than 90. Is that a problem? The answer is what level of confidence you take on the statistic. Well, how would you answer that? Well, everything is about confidence levels of intervals. You have a binomial distribution to check if it's the correct way. How would you do that? Well, excuse me for a moment, I will be back. I have to go to the bathroom. Yeah, sorry for interrupting. Well, one must find the confidence interval for an experiment of a binomial law. Are you satisfied or not? Of parameters. Well, number of clients, which is 860, and a probability p, whose confidence interval must be found given a threshold alpha. The confidence, if we take x as a number of satisfied clients, and the point is that the confidence interval is as follows: xn bar minus u0, that is a rule, between the x1 xn bar times x1 minus xn bar divided by n, and the same quantity with plus. I will explain. Who is xn bar? Xn bar means the average of the sample, x1 plus x2, meaning the average of satisfied clients, which in that case is the empirical sample, which we found it's 88.72%. Who is U0? U0 is the alpha quantile of the normal distribution. So U0 is defined in the following way: probability that minus U0 be inferior to n of 0, 1, which is on its turn also inferior to u0, should be 1 minus alpha, which should be almost equal to 1, usually 0.95%, and so on. u0 usually is the inverse distribution, plainly speaking, of this. which you can compute with a pocket computer. You find u0, xn is already fine. The point of this is that in the interval covers 90% or not. The answer is yes. You should only do some plain computations. This is the most difficult part. Usually it's for those who are really interested in probability theory. I would not recommend to go to the fourth exercise, but however, on the other three are mandatory for anyone to wishes to at least comprehend the basics of probability theory. Well, that's it for the beginning. I would soon put out some new videos regarding sequences, progressions, and so on. Good luck and enjoy math. Bye.